Welcome back, everyone. Ready for another deep dive?
Always.
Today, we're taking on a prehistoric giant, a creature that has captured the imaginations of, well, pretty much everyone who's ever heard of it.
And with good reason.
Megalodon. It's a name that evokes images of colossal teeth, monstrous jaws, and a reign of terror in the ancient oceans.
Oh, definitely. Megalodon was a force to be reckoned with.
And we're going to uncover all its secrets, from those iconic teeth to its evolutionary journey and its eventual disappearance. So, are you ready to take the plunge into the world of Megalodon?
Let's dive in.
Perfect. Now, before we get lost in the details, I have to ask, what was it about Megalodon that first grabbed your attention?
For me, it was the sheer scale of it. I mean, try picturing a shark that makes a great white look like a guppy. It's mind-blowing.
It really is. And just thinking about the power behind those jaws, I've heard they could crush a car.
Well, a car might be pushing it, but the bite force of a megalodon was undeniably immense.
So, just how big are we talking here? I mean, I know we're dealing with a prehistoric giant, but give me some perspective.
Imagine a shark the size of a school bus, or even bigger. Some estimates put Megalodon at over 50 feet long.
Wow. That's just enormous. It's hard to even wrap your head around a creature that size.
Right, and that's just based on the limited remains we have. Mostly teeth and vertebrae, since cartilage doesn't fossilize well.
Ah, yes, the famous Megalodon teeth. They're practically the poster child for this prehistoric predator. And I'm guessing those teeth played a key role in figuring out just how big Megalodon actually was.
Absolutely. Those teeth are like a window into Megalodon's world. They tell us about its size, its diet, even its hunting strategies.
Speaking of teeth, what makes Megalodon's teeth so unique? I mean, they're obviously huge, but what else sets them apart?
Well, apart from their size, Megalodon teeth are incredibly robust, with these beautiful, fine serrations, perfect for gripping and tearing through flesh and bone. And the shape is distinctive too, triangular with a thick root and a pointed tip.
It sounds like the ultimate weapon for a prehistoric predator, and I can only imagine the damage those jaws could inflict.
Studies have estimated Megalodon's bite force to be somewhere between 108,000 and 182,000 newtons.
Okay, I'll admit, I'm not entirely sure what that means in practical terms. Can you put those numbers into perspective?
Think of it this way. The strongest bite force ever recorded for a great white shark was around 18,000 newtons. Megalodon's bite was potentially 10 times more powerful.
10 times? That's insane. What kind of prey would even require that much force?
Well, Megalodon was a serious gourmand with a taste for large prey. We're talking dolphins, whales, even sperm whales.
Whoa, sperm whales.
Yeah.
Those are massive creatures. Did Megalodon have any particular hunting strategies for taking down such colossal prey?
It seems so. There's evidence suggesting they might have rammed their prey from below, targeting vital organs like the heart and lungs.
Like torpedo with teeth. Talk about a brutal attack.
It's pretty intense, right? And there's evidence suggesting that Megalodon might have even targeted the tails and flippers of larger whales, trying to immobilize them before delivering the final blow.
A bit like taking out the engines before sinking the ship. Brutal, but effective. But Megalodon wasn't exactly alone in those ancient oceans, was it? What kind of competition did it face?
Oh, there were some serious contenders out there. We're talking giant predatory sperm whales like Leviathan and other large sharks. Imagine those encounter.
It's like a prehistoric battle royale. The thought of those titans clashing is just incredible. It makes you wonder how the entire marine ecosystem functioned with such massive predators at the top of the food chain.
Absolutely. It's about understanding the interconnectedness of life and how a creature like Megalodon shaped everything around it. But that's a topic for another time.
So we've talked about Megalodon's size, its teeth, and the epic battles it might have faced against other prehistoric giants. But what about Megalodon itself as a living, breathing animal?
Well, there's so much we can learn about Megalodon's biology from the fossil record, even without a complete skeleton.
I know we've touched on this, but why is it so rare to find a complete Megalodon skeleton?
It all comes down to cartilage. Unlike bone, cartilage is much softer and doesn't preserve well over millions of years. So most of what we know comes from teeth, vertebrae, and the occasional other fossilized fragments.
And those vertebrae, those precious few we have, what can they tell us?
A surprising amount, actually. They give us clues about Megalodon's size, its growth rate, maybe even its lifespan.
So how fast did this prehistoric giant grow? I'm picturing something out of a monster movie, just ballooning in size overnight.
Not quite that dramatic, but Megalodon did grow pretty quickly. One study estimated that a 30-foot individual died at around 46 years old, with a growth rate of about 6 inches per year.
6 inches a year, that's still pretty impressive. Imagine a 2-meter-long baby megalodon swimming around.
Right. Speaking of baby megalodons, there's evidence to suggest that they might have had nursery areas in warm coastal waters, much like some shark species today.
Makes sense. Even a juvenile megalodon would have been vulnerable in the open ocean, facing threats from larger predators, maybe even other megalodons.
Exactly. It would have been a tough world out there, even for a baby giant. But those nursery areas would have provided food and protection, giving them a chance to grow.
It's fascinating to think about these ancient ecosystems teeming with all these incredible creatures. And Megalodon, with its size and appetite, must have played a huge role in that ecosystem.
Oh, absolutely. Megalodon was the apex predator of its time, sitting right at the top of the food chain. Its presence would have influenced everything from the behavior of other predators to the distribution of prey species.
Like a ripple effect, right? Megalodon's impact would have spread throughout the entire marine ecosystem. But speaking of other predators, we've talked about the competition Megalodon faced from giant sperm whales. But what about its interactions with other sharks, especially those that are still around today?
That's a great question. There's some intriguing evidence suggesting that Megalodon might have had a significant impact on the evolution and distribution of the great white shark.
Really, I'm all ears. How could Megalodon have influenced the great white?
Well, fossil records show that great whites were mostly absent from areas where Megalodon was present. This suggests that Megalodon might have outcompeted great whites for resources, forcing them into colder, less desirable waters.
So basically, Megalodon pushed the great whites out of the prime real estate.
In a way, yes. And this competition might have even driven some of the adaptations we see in great whites today, like their ability to tolerate colder temperatures.
Wow, that's amazing. It's like this ancient rivalry shaped the great white shark we know today.
But back to Megalodon itself. Is there anything else about its biology that might surprise people? Something they might not expect from a giant prehistoric shark?
Well, there's one theory that's been gaining traction in recent years. It suggests that Megalodon, unlike most sharks, might have been partially warm-blooded. Warm-blooded? A shark? That seems counterintuitive, to say the least. Aren't sharks supposed to be cold-blooded?
That's the common perception, but there's growing evidence that some ancient sharks, especially large active predators like Megalodon, might have been regionally endothermic. This means they could maintain a higher body temperature in certain parts of their body, like their muscles.
Okay, so maybe not fully warm-blooded like mammals, but definitely a step above your average cold-blooded fish. But how can scientists figure that out from fossils? It's not like they could take a prehistoric shark's temperature.
Right, it's a bit of a puzzle. But scientists have found clues by analyzing oxygen isotopes in Megalodon teeth. These isotopes can reveal information about the temperature of the environment where the teeth formed. And in Megalodon's case, the data suggests its body temperature was significantly warmer than the surrounding water.
So this is a creature that could regulate its own temperature to some extent, allowing it to thrive in a wider range of environments and maybe even outcompete its cold-blooded rivals.
Exactly. It was a huge advantage for a predator like Megalodon. And speaking of advantages, let's not forget about those spiral-shaped coprolites we discussed earlier.
Ah, yes. Fossilized shark poop.
Hmm.
Not the most glamorous topic, but I know you're excited about this. What can Megalodon's leavings tell us?
Well, those coprolites, found in places like South Carolina, give us more insights into Megalodon's biology. Their spiral shape suggests that, like many modern sharks, Megalodon had a spiral valve in its intestines.
A spiral valve. Now, for those of us who aren't marine biologists, what exactly is that?
It's basically a corkscrew-shaped structure in the lower intestines that increases the surface area for nutrient absorption. It allows the shark to extract as much goodness as possible from its food, which would have been crucial for a giant predator like Megalodon.
So, Megalodon had a specialized digestive system to fuel its massive body and high-energy lifestyle. It's amazing what scientists can glean from fossilized remains, even poop. But let's get back to the big picture. We've talked about size, teeth, hunting strategies, even poop, but is there anything about Megalodon that might surprise people? Something that challenges our usual assumptions about this prehistoric giant?
Well, one often overlooked aspect is that Megalodon, despite its size and power, was ultimately a product of its environment. Just like any other creature, it was shaped by the forces of evolution, adapting to the challenges and opportunities of its time.
It's a humbling thought, isn't it? Even a creature as massive and powerful as Megalodon was ultimately at the mercy of its environment. But that brings us to the big question that's been looming over our entire conversation.
The extinction.
Exactly. What happened? Why isn't this incredible creature still ruling the oceans today?
Well, like most things in paleontology, it's not a simple answer. The extinction of a species, especially one as dominant as Megalodon, is rarely caused by a single event. It's more like a confluence of factors, a perfect storm, if you will.
So what were the ingredients in this perfect storm that brought down the mighty Megalodon?
Well, one of the prime suspects is climate change.
Climate change.
Uh,
Even millions of years ago.
Oh, yeah. The Earth's climate has always been in flux. And during Megalodon's reign, the planet experienced a significant cooling trend. Glaciers formed at the poles, ocean currents shifted, and sea levels dropped.
And these changes would have had a direct impact on Megalodon's habitat, right?
Precisely. Megalodon seems to have preferred warmer waters. As the oceans cooled, suitable habitats would have shrunk, potentially squeezing Megalodon populations into smaller and smaller areas.
And less space means more competition for resources.
Exactly. And that competition wasn't just with other megalodons. They were also vying for food with other large predators, including those giant sperm whales we talked about earlier.
So, a shrinking habitat, increased competition. What else was working against Megalodon?
Well, the cooling trend also impacted Megalodon's food supply. The diversity of baleen whales, one of Megalodon's primary food sources, declined dramatically towards the end of the Miocene.
So not only was their habitat shrinking, but their menu was getting smaller too.
Pretty much. And to make matters worse, the whale species that did survive were evolving, becoming faster, more agile, and potentially harder for Megalodon to hunt.
It sounds like Megalodon was facing a real crisis. But was climate change and dwindling food supply the whole story? I've also heard that the rise of new predators might have played a role.
You're right. Around the same time that Megalodon was facing these environmental pressures, we see the emergence of some very capable competitors.
Yeah.
Specifically, early killer whales.
Ah, yes, the wolves of the sea.
Exactly. And these early killer whales, like Orcinus cytoniensis, may have been particularly adept at hunting the same prey that Megalodon relied on.
So not only was Megalodon dealing with a changing climate and a shrinking food supply, but it also had to contend with these new, highly intelligent predators.
Right. Killer whales are incredibly social animals, hunting in packs and using sophisticated strategies. This might have given them an edge, especially in a world where prey was becoming scarcer.
It's fascinating, isn't it? This interplay between environmental change, competition, and evolution. It really paints a picture of how dynamic life on Earth truly is.
I agree. And while Megalodon's extinction might seem like a tragic end to a magnificent creature, it also opened up opportunities for other species to thrive. It's a reminder that extinction is a natural part of evolution, a process that has been shaping life on our planet for billions of years.
Well said. And it underscores the importance of understanding these ancient ecosystems. They offer a glimpse into the past, but they also provide valuable lessons about the interconnectedness of life and the delicate balance of nature.
Absolutely. By studying the rise and fall of creatures like Megalodon, we can gain a deeper appreciation for the complexities of our planet's history and the forces that continue to shape the world around us.
Well, I think it's safe to say that our deep dive into the world of Megalodon has been a truly awe-inspiring journey. We've explored its size, its biology, its hunting strategies, and the factors that ultimately led to its extinction. And we've done it all without even mentioning the movie.
Exactly, because the real story of Megalodon is far more fascinating than any Hollywood blockbuster. It's a story that combines scientific discovery, incredible fossils, and a touch of prehistoric drama.
It's a story that reminds us of the vastness of time, the incredible diversity of life that has existed on our planet, and the power of change to shape the world around us.
And who knows what other mysteries are still waiting to be uncovered in the fossil record. Maybe one of our listeners will be the one to make the next big discovery.
That's a great thought to end on. To all our listeners, thank you for joining us on this deep dive into the world of Megalodon. Until next time, keep exploring, keep questioning, and never stop learning.